Picture this. You're sitting in your high-stakes Cambridge IGCSE computer science exam. The clock is ticking down. You read a question about data transmission to a robotic arm, and you confidently write down, simplex means data goes to the robot. You put your pen down, thinking you absolutely nailed it. But do you actually get the mark for that? No way. You get a 0.
So why is that? Well, it all comes down to vague wording. In computer science, just stating the name of a device or saying data goes somewhere simply isn't going to cut it. Compare that vague answer to a specific mark scheme-safe response. Data travels in a single, permanent, one-way direction from the sender to the robot. See the difference? That explicitly identifies the direction of the data, and that gets you full marks.
And right there is the trap. Just naming a device without explaining its specific transmission process will literally cost you the grade. Honestly, 9 out of 10 students get caught out by this exact mistake, quietly bleeding points on questions they actually know the answers to. But don't worry, I'm going to show you exactly how to fix this before you ever set foot in the exam hall.
Welcome to this explainer. I am so thrilled to have you here. Today, our mission is simple but incredibly powerful. We're taking standard syllabus definitions and transforming them into a high-stakes visual exam survival guide. We are going to completely bridge the gap between just knowing a concept and knowing exactly how an examiner wants you to write it down.
Here's our agenda for today. First, we'll cover avoid common exam traps, then mastering data transmission modes, demystifying TCP/IP protocols, cracking CPU core functions, and finally, buses and data transfer. Let's dive right in.
Section 1. Avoid common exam traps.
Okay, so the absolute most crucial thing here is understanding your command words. These are those specific verbs sitting right at the start of a prompt. For instance, an explain question requires the how and the why, giving characteristics and reasons. On the flip side, a state or define question just needs a concise, precise definition. If you state when you're supposed to explain, you're just leaving marks on the table. You can completely avoid generic responses and virtually guarantee full marks by filtering every single answer through this simple 4-question self-check loop. What is it? How does it work? Where is it used? And why is it used? If your answer hits all 4 of these points, you have built an unbreakable response. Moving right along to Section 2, Mastering Data Transmission Modes.
We're always going to start with what I call Layer 1, everyday language. Before we get into the heavy technical jargon, we really need to establish the core purpose. Data transmission is simply moving information from a sender to a receiver. It's literally the digital equivalent of mailing a letter or making a phone call.
Now let's take a look at this image we have up on screen. It perfectly lays out the 3 actual modes of transmission. Simplex is one way only. Data travels in a single, permanent direction, like a keyboard sending data to a monitor. Then we've got half-duplex. This is two-way but non-simultaneous. Data travels in both directions but crucially only one direction at a time, kind of like a walkie-talkie. Finally, full duplex is two-way simultaneous, meaning data travels in both directions at the exact same time, like your broadband internet connection. So how do you shape those definitions into an exam-ready response? You've got to follow the precise exam reasoning path. First, run through the 4-prompt memory check we just talked about. Second, avoid generic answers by always anchoring your explanation to the specific scenario given in the question, like a robot or a database. And third, ensure your wording regarding direction is exact and totally unambiguous. All right, Section 3, Demystifying TCP/IP protocols. Once again, stripping away all that complex networking jargon, our Layer 1 everyday definition is just this. A protocol is an agreed-upon set of rules that allows 2 computers to actually understand each other and have a successful conversation. It's just the ground rules for chatting. Check out this full-screen visual. To build a bridge between simply describing a protocol and actually explaining it, you have to cross from description, which is just identifying the device or process, over to explanation, which details exactly how and why it's used. You can't just name-drop TCP/IP and hope for the best. Notice the context-specific applications here: a school, a bank, a smart home. You must always tailor your explanation to the exact scenario the examiner provides and verify it with our trusty 4-question self-check. Let's shift gears now. Section 4, Cracking CPU core functions. Before we start looking at the intricate architecture of a motherboard, let's go back to our Layer 1 everyday language. The CPU is essentially the brain of the computer. Its entire job, day in and day out, is to tirelessly fetch instructions,
decode them to figure out what to do, and then execute them step by step.
Looking at this visual, the three-layer mastery path always begins with that common Layer 1, everyday language. But then, you must upgrade to Layer 2, technical vocabulary. You have to replace those general terms with precise computer science terminology. Finally, you reach Layer 3, the exam-ready response. This is exactly where you shape that technical idea into a structured, timed answer designed specifically to score points, all backed up by your quality control self-check.
So, the real game changer when you're facing a complex CPU question is to use this four-step sequence. 1. Identify the exact concept. 2. Explain the process in a logical, step-by-step sequence. You want to avoid jumping forward or backward. Trust me, examiners hate it when you explain the end of a process before the beginning. 3. Apply it to the context. And 4. Run that self-check.
And that brings us to our final core topic, Section 5, Buses and Data Transfer.
Back to Layer 1. I want you to think of a computer's buses like physical highways, and the data they carry as digital delivery trucks, moving tangible results all across the motherboard between the different components. Taking a look at this detailed slide, you can see how to translate this into technical reality by following a disciplined exam path. Moving from everyday language right into Layer 2, we have 3 distinct buses connecting the CPU and memory. The data bus carries the actual data. The address bus carries the location of where that data needs to go, and the control bus carries the signals managing the operations. To successfully describe this interaction, you just move logically from classifying the concept to sequencing the steps and then applying the real-world context. When you actually sit down to write your answer, you've got to always order your steps chronologically. Name the exact bus, state its specific payload, like is it carrying data, an address, or control signals, define its direction of travel, is it one-way or two-way, and finally, link it right back to the real-world scenario provided in the prompt. If you do this, your examiner can easily follow the exact mechanism without getting lost. Okay, let's put everything we've learned today into practice with a quick interactive challenge. Look at the student's answer. The smart home uses half duplex so it can send and receive data. Can you spot the missing technical criteria? What exactly is keeping this from getting full marks? Think back to our definitions of transmission modes.
By applying our trusty self-check loop, we add the vital missing piece, but crucially, only in one direction at a time. That one specific phrasing upgrades a vague answer to full marks. It just goes to show that structured understanding will always beat blind memorization. If fixing this one single sentence can guarantee you points, imagine how mastering the underlying logic of the entire syllabus could completely transform your exam results. Are you ready to stop memorizing and start truly understanding? Because that's how you ace these exams.